welcome to another live weather and climate office hour. I suppose today will actually be a mixed geohazards office hour because despite my primary role as a weather and climate scientist, I am also an Earth systems scientist and someone who holistically considers geohazards as well in my professional role. So I did want to add a bonus discussion today about the tsunami alert kerfuffle, I guess we could call it, earlier this week. So that'll be some bonus content beyond what I had already planned to discuss today. And also, just in the last half an hour, it looks like there was a decent shaker in Southern California. Nothing damaging or dramatic, but another reminder that California is a seismically active area with a low mid-4 magnitude quake near Rialto that triggered a cell phone emergency alert warning for a number of folks in Southern California that some people did receive once again before the shaking started in their location. I can't quite get over how remarkable that modality is, given where we were even 10 years ago, when that really was still something that we were looking to the future that might be possible. And now it's quite common to get those shake alerts when there's a distant earthquake that might affect your area in California and expanding to broader parts of the West Coast too. So what I do want to talk about today, that's probably all about that earthquake unless something else happens, because it was pretty modest in magnitude. I will begin briefly by talking about what happened with the much larger earthquake in the Western Pacific and the subsequent tsunami alerts this week in California. But the main content today is that I wanted to reflect more on what has now that we're at the end of July, it has indeed been an unusually cool July, not only along the coast in California, though especially there, but also across a much wider swath of the interior of California than was true last month. Though in June, in fact, California as a state was in fact much warmer than the long-term average for June, and was very warm across inland areas and mountain areas. That has not been the case in July. We can now say pretty definitively, as we're in the final hours of the month. But there is a strong expectation, and yes, I realize I've said this before, that the much greater heat is imminent. But this time there are actually signs that the ocean is cooperating, and that was not necessarily true a couple of weeks back. So I'll talk about that as well, sort of as the core content of this session. And then I also do want to touch upon what's going on at the federal level with respect to weather, climate, and disasters. There have been a lot of updates in the past couple of weeks, and they are genuinely mixed. Some actually are in a more positive direction than I've been talking about recently. Some are actually extremely concerning, so I'll talk about those in this session as well. So a bit of a smorgasbord of Earth system and natural hazards topics today. As always, it's helpful if you share these sessions while they are live. That is one of the things that the YouTube algorithm likes. If you value these sessions, it's most helpful if you share them while other people can join contemporaneously. So thanks for that. And again, a reminder that this channel is partially sponsored by Reask, a climate tech company that's helped rethinking weather and climate risk in a warming world. Certainly relevant to today's discussion, as it often is on this channel. Okay, so I don't really have any graphics necessarily I'm going to show for the brief bonus tsunami kerfuffle discussion I wanted to have at the beginning here. But mainly, I'll just offer by means of a summary, because I think most people have some awareness of the fact this transpired on, I guess it would have been Tuesday night, Pacific time. And the basic summary is this. There was a really big earthquake. In fact, it was one of the 10 highest magnitude earthquakes recorded in the modern era in the West Pacific, not far from the coast of Kamchatka. So that's in eastern Russia. And there was significant damage along the coast from the shaking of this high magnitude earthquake in Kamchatka. There's not a huge number of people who live there, but there is one major port city, and there was damage there. And there was also a significant local tsunami. And again, just for clarity, a tsunami is not a cresting ocean wave like a lot of people think of them, but is in fact a wall of displaced water. And so while a 3 to 5 foot cresting ocean wave might be quite unremarkable, something that may not even be large enough to attract the attention of more expert surfers out there, a 3 to 5 foot tsunami is more like a temporary 3 to 5 foot elevation of sea level. So it's a very different process. It is far more energetic and more dangerous at an equivalent height. So you don't necessarily need to have very high tsunami heights to cause significant danger or damage along the coast or places close to sea level. So there was a damaging tsunami in the Russian Far East that washed a bunch of coastal structures into the ocean, and vehicles into the ocean, things like that. There was concern, given the magnitude, the 8.9 magnitude quake, and its location on a subduction zone, that the focal mechanism of this earthquake might have vertically displaced a lot of water that was spreading primarily in an eastward direction across the Pacific Basin. And there is a long history of quakes like this, including some very close to the epicenter of this one, sending a large damaging tsunami all the way across the Pacific Basin, affecting places along the Pacific coast and Hawaii and even the Pacific coast of South America, thousands of miles away in the opposite hemisphere, perhaps even sending tsunami waves to Antarctica. So without getting into the science, too deeply into the science of tsunamis, and again, I'm not a seismologist or a solid Earth geophysicist, more of a fluid Earth geophysicist, if you will. The atmosphere is a fluid, but the ocean is a fluid too, and some of the same dynamics apply. But in any case, there was initially a significant concern that a basin-wide potentially damaging tsunami could affect areas all the way from Alaska to California to South America, including Hawaii and the West Pacific. So initially, right after this big quake, the NOAA, which is the agency responsible for issuing tsunami watches, warnings, and advisories, and assessing the hazards, initially issued a tsunami watch. And this is mainly what I wanted to talk about today, which is the difference in nomenclature and the reasons why different kinds of language is used to describe various physical hazards. In this case, it was a tsunami or a potential tsunami, but actually the same language and logic applies to floods, as we were talking about earlier this summer in the context of Texas, and the misunderstood warnings and watches that were issued then. And it also applies in places like California with floods or high wind events, even, for example, fire weather events. I'll talk about all of this briefly in this first bit. But the real part I wanted to emphasize was when there is a tsunami watch, what that means is that there has been an event, usually an earthquake, that has occurred with a magnitude and in a position where such that a tsunami of indeterminate magnitude is possible. Essentially, it's a signal that, something significant just happened that could potentially generate a tsunami. We don't know the details yet. We don't know how big it would be. It could be very large or it could be negligible. So be on the lookout and stay tuned for further updates. So the watch means we have time to figure this out. There will be scientists analyzing this frantically behind the scenes, crunching the numbers. But until we figure out exactly what the situation is, hold tight and prepare if a warning is issued, essentially that much urgent action might be required, including evacuations, things like that. But a watch is hold your horses, pay attention, and probably it isn't a good day to go out pleasure boating. So stay tuned to what happens next. There are two things, or really three things, that can happen after a watch is issued. If a tsunami watch is issued, it can be definitively upgraded to a tsunami warning, meaning that a tsunami of significant or damaging magnitude is now expected, so imminent or likely. that's the real alarm signal. That means, okay, it's time to put your tsunami plans into action. There may be evacuations required of some coastal areas depending on the magnitude of the predicted tsunami. But a tsunami warning is a signal that there is a substantial possibility of a significantly damaging tsunami. So not just little surges at the coast or irregular currents, but an actual substantive inundation of significant portions of normally dry land. But the other thing that can happen upon analysis by the Tsunami Warning Center can be a change from a tsunami watch transitioning to a tsunami advisory, which is a lesser alert than a tsunami warning. So tsunami advisory means, yes, a tsunami does appear like it was generated, but it does not appear to be especially large or very likely to be destructive. So both a warning and an advisory in this case are confirmation that a tsunami is expected, but an advisory suggests that significant public action is unlikely to be necessary. Mass evacuations probably won't be necessary because the magnitude of the tsunami will be relatively small. So widespread inundation of normally dry land is probably not going to occur at your location during this event, whereas a warning means that in fact there could be major inundation of normally dry areas. So the required actions for a tsunami advisory are less, unless you are on the beach or on a boat near the coast or on a dock in a harbor. You probably don't need to do anything if there's an advisory. It just means don't go surfing, don't go stand on the beach and watch the waves come in. If you're in a small craft, put it somewhere safe and don't hang out on the docks. It really isn't a big deal unless you're in one of those locations. Now, it can be dangerous if you are in one of those spots, which is why these alerts are issued. But a tsunami advisory is definitively a lesser alert than a tsunami warning. Now, a tsunami warning might actually require that people even blocks inland evacuate to higher ground. In low-lying areas, perhaps as much as a mile or two inland, depending on the magnitude of the expected event. But a warning would be issued in that case. That's when local officials would order evacuations of coastal areas, whether you might hear sirens or emergency alerts go off. That isn't going to happen for an advisory. And I understand why a lot of folks were confused by this. There was pretty mass confusion. Local government officials, members of the U.S. Senate, local emergency managers, almost every news outlet that posted their initial social media posts and headlines on their websites got it wrong, which is a little bit concerning, but I understand why. One, the U.S. Tsunami Alert website is very poor. It's been chronically underfunded, and many of the people who are responsible for maintaining it were fired earlier this year. Yes, this is related to the Doge cuts. So this is something that has been in urgent need of an upgrade for many years. I think that need has become even more obvious now. Again, this is not to say that the predictions were bad. This is just like Texas. In fact, the predictions were actually very good. And ultimately, a tsunami warning was not issued for most of the Pacific coast, except for an isolated part of the north coast of California near Crescent City, due to the local effects of the bay there, Crescent City Bay, which can amplify the magnitude of a tsunami. And so the decision was made to issue a localized warning upgrade from an advisory there. Not because the tsunami was expected to be huge, but was expected to be 5 or 6 feet. Now, I'm over 6 feet tall. That may not sound like a lot, but as I mentioned, this is different from a 6-foot cresting ocean wave. This is a temporary elevation of all of the water by 5 or 6 feet, and so that can still be a problem. And there was some inundation of coastal parking lots and harbors and things like that, and so it probably made sense to issue that warning, because if you happened to be sitting in a parking lot along the harbor, that could have been a problem for you. This was not a devastating tsunami for the West Coast, fortunately, nor was it for Hawaii, but there again, there was inundation of coastal parking lots and some beaches, and it is a good thing that people were not on them when that 6-foot wall of water came on shore. It doesn't sound as terrifying, perhaps, as a 50-foot wall of water, which you can get in the very most extreme tsunami events, but nonetheless, it's something that if you can easily avoid by just going a block or two inland, it would make sense to do. So this was an event that there's a lot of folks saying, oh, there was so much hype, it was overblown. But that's really not true, because a tsunami watch was issued, it's true, for much of the Pacific Rim, including California. But that just meant we don't know how big it's going to be yet. Give us half an hour to crunch the numbers. We'll come back to you in half an hour. You have plenty of time regardless, because it would take hours for this to cross the Pacific. So sit tight, we'll see what happens. They crunched the numbers, determined that the tsunami had been generated, but that it would probably not be very big. And so instead of issuing a warning, issued a lesser advisory, which appears to have been exactly right. And the tsunami heights in almost all of the Pacific ended up being within a couple of feet of those predicted, despite, again, many claims to the contrary. This language, this escalatory language from NOAA is actually very similar to how a lot of extreme weather alerts and warnings are issued. So think about flood watch, for example. This was the problem in Texas. A flood watch was indeed issued for the Texas Hill Country before the catastrophic floods earlier this month. And that means that a flood is a significant flood is possible somewhere in the watch area, but we don't know exactly where and exactly when. But be on the lookout, and if we issue a warning, which we will do probably for some areas later, that is when it is time to take urgent action. Same thing with the tsunami watch versus warning. There's also a lesser pathway for flooding in the Weather Service lingo. You can go from a watch to a flood advisory, which means that, again, that flooding is likely or has been confirmed, but probably will not be of a particularly serious magnitude. So again, if you drive into a flooded underpass or something, that could still be bad for you personally, but it is unlikely to be a historic or catastrophic event. The usual areas that often flood will maybe flood, and relatively routine precaution will be enough to keep people safe. That's what an advisory is intended to connote. Same thing with high wind warning. You can have a high wind watch. We see these often in California during winter storms or offshore wind events. It means that high winds are possible within the next couple of days. We don't know the exact magnitude yet, and we'll issue either a high wind warning if the magnitude is going to be very high, or a wind advisory if the magnitude will be elevated but probably not seriously dangerous or damaging. So that the language is similar. There's a number of situations like this where the difference between a watch and a warning and an advisory is really important to understand. And this is true especially if you are in local government, if you are an emergency official, or you are a journalist reporting on these things. I'm raising this because it appears that all three categories of people apparently did not really understand the difference between a watch, a warning, and an advisory, both in the Texas case with tragic outcomes, and then in the California case just this week with the tsunami alert, even though that did not have, fortunately, tragic outcomes and nobody died because there was not a very large tsunami. The challenge here is that you can imagine a version of the fairy tale about the public agency that cried wolf, or at least the public agency that was perceived to have cried wolf, even if it did in fact not do so too many times historically, and then nobody listens when the big one really comes. This is one of the challenges, is balancing the fact that there's always so much social media hype about everything, so everything gets ramped up to 11, except that sometimes, rarely, but sometimes there are 11 out of 10 extreme events, and then nobody really is able to differentiate between the hype of the events that aren't extreme from the truly extreme events that sometimes really do require our full undivided attention. So hopefully that offers some helpful context and generalizes it past just this tsunami event, which, again, there was a tsunami. In fact, the sloshing of the ocean level only ended this morning. The tsunami event lasted for almost 2 days and was measurable at tidal gauges all throughout the Pacific, including in California. But fortunately, it just wasn't really a very damaging event outside of Kamchatka, close to the epicenter. Okay, so enough about the solid Earth. Unless something else happens during this hour, I'm done with the solid Earth part of this conversation. Knock on wood. I'll keep an eye on the comments in case something happens. Okay, so the next thing I wanted to talk about is further reflection on the cool conditions in California this July, and along the coast also in May and June. So there's really two different things going on. And I've talked about the mechanisms behind this more in the last live stream, so these are always recorded, by the way, so feel free to go check that out if you want the long version of the mechanisms. Also, my most recent blog post at weatherwest.com talks about that in some more depth. But the basic thing is that really two things have been going on. One is that the nearshore ocean has been really cold, so the actual sea surface temperatures along the central and northern California coast have been at least several degrees below their average levels for June and July this year. That has meant that there has been a really kind of cold and clammy marine layer that's affected everywhere from the north coast down to especially the San Francisco and Monterey Bay areas. So San Francisco has sort of been the poster child for this unusually cold summer pattern. And the cold ocean water there is the main reason for that. And it's been so cold that this really cold coastal influence has even spilled inland, not just across the Bay Area, but even through the coastal gaps. So through the Carquinez Strait, affecting the southern Sacramento Valley, the northern San Joaquin Valley as well as the immediate coastal zone. The higher elevations, once you get up above 1,000 or 2,000 feet in the coastal hills, have not been. So once you're above the marine layer, there is a bit of an inversion where it's been a lot warmer, but still not notably warm in July. So that's one thing that's been going on. That's been true about since May. So this has been pretty persistent now for a better part of 3 months along the immediate coast. But in May and June, inland, we did not have the same situation. In fact, May and June were very warm across inland portions of California. Mountain and interior parts of California saw a top 10 warmest May and June on record again. And I know that folks are very upset for some reason when I've been pointing that out. I've been getting a lot of angry emails about this, but it is in fact quantitatively true. Now, that was because there was ambient ridging aloft that was keeping this strong inversion in place. So very warm air aloft was keeping the mountains and the upper valleys across the interior of California much warmer than their May and June averages. Sort of the squashed but very chilly marine layer, on the other hand, was keeping San Francisco and coastal areas and coastally influenced areas, including through the San Joaquin, Sacramento Delta region, cooler as well. But in July, things got even a little more interesting, because in July, this cold water along the coast continued. And again, it's been cold because of the vertical upwelling of cold water in the ocean from the deep. So there's always upwelling this time of year along the coast, but it's been stronger than average so far this year, and therefore the surface temperatures have been cooler than average. But in July, what we actually saw was some anomalous troughing. So essentially low pressure in the middle atmospheric levels, not just cool air along the coast. So now in July, for much of July, what we actually ended up having was cooler than average temperatures across a broader portion of the state. Still not the entire state, and I'll show this in a minute, but it is true that July, now that we're at the 31st, has in fact been a cooler than average month across most of California, including areas significantly farther inland than this was true for in May and June. So I'll show a map depicting this in a moment. It's still been warmer than average, by the way, across the northern and eastern mountains, even in July, believe it or not. But that is definitely the minority situation in California in July. That is not consistent with seasonal predictions for July, so I think that's pretty clear as we've gotten to the end of July. But it's also not appropriate to evaluate seasonal predictions, which again are sort of 3-month smooth windows, using a single month. And the canonical summer season, June, July, and August, is a 3-month period. I would argue that in much of California we should probably shift it later by a month, sort of centering it on August, so July, August, September. But in any case, July is but 1 month of a season. And June was warmer than average in the vast majority of California except for the immediate coast. July has now been cooler than average in most of California. So we will see what happens in August or September, depending on how you align your seasons. In coastal California, it's worth reminding folks that the warmest months of the year are almost always August, September, or October. So the big heat waves at the coast normally wouldn't have occurred yet anyway, but even in that context, it has been quite chilly. So I'll also talk about looking forward a bit as well, and just point out we can't evaluate a seasonal summer prediction at the end of July. At a minimum, we need August too. And arguably, the peak warm months in a lot of California would require us also to consider September. So I'll get into that in a moment. I'll show some maps. But the other thing that's happened with this unsettled pattern in July, with this troughiness, is we've actually had some genuinely notable precipitation across the interior of Northern California. Now, this hasn't really affected Sacramento, or San Francisco's gotten some marine layer drizzle, but that's pretty localized. But where we have seen notable precipitation is in the form of scattered mountain thunderstorms on quite a few days in the past few weeks in the northern mountains in the Sierra Nevada. And these are not the usual monsoonal storms you might see with moisture and instability coming up from the southeast, but these are sort of from the cyclonic area of spin over Northern California itself. And so the northern coast ranges in the Klamath Mountains have actually been pretty active. There have been a number of severe thunderstorm warnings and even a couple of flash flood warnings from heavy downpours. We've also seen many dozens of wildfire ignitions from lightning strikes, even though these storms haven't been dry thunderstorms for the most part per se. They've been associated with downpours. We have been seeing lightning strikes outside of these relatively narrow rain cores. So while some places have actually seen localized flooding, believe it or not, including Wairika, which has seen record-breaking rainfall, I believe, twice this summer, notably. They've just been hit by very intense localized downpours on multiple occasions. It's a pretty dry part of the state. We've seen this mix of unusual precipitation, quite a few natural wildfire ignitions. Again, lightning is a natural source for wildfire ignitions. Some of these have gone pretty big. A couple of these fires have burned a couple tens of thousands of acres, which again is large, but not enormous in the context of recent decades. And also, they haven't really caused a lot of harm. One could argue that most of the burning that's been going on in the northern third of the state from lightning this summer so far has been probably more beneficial than has been harmful. But in any case, what it does mean is that there are probably a lot of low-intensity fires smoldering out there from a lot of these lightning strikes. There was a record amount of lightning in the last couple of weeks, at least relative to the decade or so, and we've been keeping track of this. So I would expect there'll be a bunch of new lightning strike fires popping up in the coming days, especially, as I mentioned, things are going to heat up there, and so some of these will come to life. We've seen a large number of lightning ignitions recently up in the Great Basin and Oregon and Washington, and a couple of really large fires that have been more damaging in northern Arizona and in Utah right now. The Dragon Bravo fire, now over 100,000 acres on the north rim of the Grand Canyon, which destroyed most of the North Rim Grand Canyon park infrastructure. This fire has been sort of going into beast mode every afternoon with record dry conditions. They've seen very hot conditions in northern Arizona. We've also seen a relatively failed start to the monsoon this year in the western flank of the monsoon region. So for Arizona, Utah, Nevada, so the Great Basin, and southeastern California, it's not only has it been much hotter there than in coastal California, but it's also been really dry. So wildfire season is lingering much later in the summer there than it would normally. This is a potential concern for firefighting resource availability once the Pacific Coast fire season heats up in the coming month or so. But in any case, not too many fires of concern in California right now, even though there are a bunch of low-intensity lightning ignitions skunking around in the northern forests. For now, most of them are probably just doing offering some benefits in the form of low to medium intensity fires in places where we haven't gotten a chance to do prescribed burning recently. That could change. Some of these very same fires could take off later when it gets hotter and windier, and that is a concern, but for now, these are not particularly threatening fires. So let me show some graphics here. I think that would be an appropriate time to do this. Okay, so you'll see my infinite mirror once again. Okay, so a few things I'd like to show. First, I guess I'll go to watch duty and give the west wide view, bring my drawing tool up just to talk about the fire context a bit. You can see there's a handful of new lightning fires burning in California, as well as a handful of largely contained lightning fires from the past few weeks, but really not too much going on. There is some activity in far northern California. There's actually a red flag warning up there right now for lightning, and there's a red flag warning across a broader region of eastern Oregon and southern Idaho, Snake River Plain. There's a whole lot of recent wildfire ignitions up here, mainly from lightning, and a growing number also up in the Pacific Northwest and the northern Rockies, as well as this elevated activity in Arizona and New Mexico. So that's what we're currently seeing right now. We zoom in on a couple of the big fires I mentioned. Here's the Dragon Bravo fire, over 100,000 acres now. So this has been a really high intensity, really active fire, moving from the Grand Canyon National Park up into the Kaibab National Forest. Not a lot of not very many people live here, but it is very flammable forest, and unfortunately weather conditions and drought conditions and record heat in some cases, and dryness have promoted a really active fire environment. This is not going to be out anytime soon. And similarly, the Monroe Canyon fire, this is closer to where people live in Utah. This is a 50,000 acre fire. Again, starting to affect more populated areas as adverse weather conditions continue. Red flag warning from there. So just wanted to give the big picture here. If we look at satellite imagery and we actually go over to shortwave infrared, we can actually see both of those fires already, even though it's still mid-morning. You can see those fires in northern Arizona already putting up a major heat signature. Again, those two black dots are different sides of the same fire. It gives a sense of how big that is. And then the Monroe Canyon fire in Utah. No visible hotspots, notably, at this point in California. Okay, so the other thing I wanted to show, here's the big picture of current ocean temperature anomalies. And as always, I just want to point out that there is far more red, orange, and yellow than there is blue on this map, meaning that the oceans are perpetually warmer than the long-term average because they are getting warmer in a warming climate. But what's of interest right now are the particularly pronounced blobs, one of which is near Japan. So the West Pacific, we're talking sea surface temperature anomalies near 10 Fahrenheit, so exceeding 5 degrees centigrade. Japan has been experiencing all-time record heat, an absolutely miserable summer of record-breaking heat and humidity. Japan is quite a hot and humid place this time of year, and this year is literally the hottest and most humid conditions that have ever been observed in significant portions of Japan. The other thing I wanted to point out is that this swath of extremely anomalously warm water extends all the way across the Pacific. Until a week or two ago, it kind of ended here, where there was a big blob of cooler than average water all along the west coast. That has changed, and this is significantly different. This blob of really, it's not even really a blob, it's a multi-thousand mile long swath of really warm water relative to average. It now extends essentially all the way to the Pacific coast, and that is a change from recent weeks. Notice we see some of these beautiful ocean eddies in the El Nino region of the eastern tropical Pacific, but right now, neither El Nino nor La Nina conditions dominating, kind of just warm and cool anomalies swirling around. But I did want to zoom in a little bit. Here is the closer picture for the blobbiness. As you can see, the unusually warm water starts around Hawaii and kind of extends now essentially all the way to the Pacific coast and going way west to Japan. So instead of ending around here as it did earlier in the summer, this has really advanced as the summer has gone on, and the warm water has now reached, in fact, as of the last 48 hours, the northern and central California coast. So instead of having super chilly anomalies in the upwelling zone, not only have we gotten rid of those, we've actually replaced them with water temperatures that are a degree or so centigrade above average. That's a large swing from recent days and weeks. In fact, you can see that. Here is a temperature change map. This is how much the water temperature has changed over the last 7 days. You can see down by the equator, you see this kind of random ocean eddies. You see the blobs of warm and cool. You kind of see a region around here where there hasn't been much net change. But look at this. Look at this rapid warming just west of California, and yes, now even right along the northern and central California coast. That is several degrees centigrade, or you multiply by 1.9 to get Fahrenheit, change in just 1 week. So there's been a lot of ocean warming in this region just over the past week. This is going to affect the rest of the summer because, as I mentioned, that really chilly blob right along the coast, if I go back to this plot here, that has disappeared. There's a little bit of cool water in a very narrow patch right along the central coast right now, but the water west of Marin and San Francisco and the north coast is no longer cool. In fact, it is now a couple of degrees warmer than average, and people have already started to note that the edge has come off the marine chill. Again, this is not just the seasonal warming of the ocean that we would normally expect heading into August. That there is some of that, but this is anomalous relative to what we would normally expect in late July, meaning that the water has really radically jumped from much cooler than average to slightly warmer than average. Southern California, a bit more of a mixed picture with some slight warm anomalies right along the immediate coast, but nothing too remarkable at the moment, kind of mixed. But the central and northern California coast transition has been dramatic, and this extremely warm blob across the entire North Pacific has really shifted much closer to the California coast. Okay. What do I want to show next here? So I think I'll do this. Here again, using climatetoolbox.org, a great tool out there. Here is the mean temperature percentile, meaning the rank in the historical record for the last 30 days. So this is 2 days lag, so it's really from the last day in June to July 29th. But you can this is essentially a proxy for the month of July. And indeed, the majority of California was cooler than average. I think that is quite fair to say. As I pointed out, it still actually wasn't true in the northeastern and northernmost parts of the state, where, again, the highest elevation regions remained notably warmer than average, but that is, and also the Imperial Valley, interestingly, but in general, and especially for all of California's major population centers, so really if we kind of draw a more specific blob here, everything west of that line, which includes almost all of California's population, was either was anywhere from slightly to well below average in terms of temperatures in July. And the most interesting, I think the most notable pieces here are this swath from the north coast through most of the San Francisco and Monterey Bay areas and parts of the central coast. These are areas where if you look at the rank here, that actually experienced the coldest such 30-day period, essentially the coldest July in the last 40 years or so. Notably, again, this would not have been a remarkably cold summer a century ago because of the climate warming that has occurred. But because we haven't seen a great deal of warming along the immediate coast in the last 40 years, in July at least, or at least at this time of year, this is a pretty notable signal. So this does mean that if you're under the age of 40, this probably was the coolest July that you've experienced in portions of the Bay Area, for example. So it's not your imagination, and it is true that along the immediate coast, July was remarkable. Now, if we sort of look at this transition zone inland and sort of exclude the immediate coast, this is a part of California that includes much of the Central Valley. That was indeed cooler than average in July, although certainly not remarkably so, only falling into, in most cases, the coolest third of years since 1979. Wouldn't even fall into the below average years prior to 1950 because, again, of that warming, that shifting baseline effect. But relative to the last 40 years, we haven't seen this much dark blue on a map in a long time. Again, this does not mean record cold since the 1800s when we have records. It's just that this particular data set only goes back to 1979, and all of the colder years in the database going back to the 1800s actually occurred prior to that point because of the long-term warming trend. So, but for all of California's major population centers, we talk about San Francisco Bay Area, we talk about Sacramento, we talk about LA area, San Diego area. This was indeed, and even the southern valley, the San Joaquin Valley cities, this was a cool July. It was not, however, for most of the rest of the West. As you can see, July, although not record-breaking in most places, was squarely in the upper third or even the top 10% of all Julys on record. So once again, California's experience does not generalize. But here's the other thing I wanted to point out. If we just look at the last 60 days, again, this is essentially more of a summer to date. Technically, this starts on May 31st, but you get the idea. This is effectively a proxy for June and July together. You show a pretty different picture. Even if we factor in this cooler July, most of the interior of California has still experienced warmer than average conditions for the summer to date. In fact, there's even some pockets of the interior that are near record warmth for this period. And if we look across the Great Basin, we actually see that most of it was remarkably, if not record-breakingly warm. So in the context of the summer so far, it remains essentially the immediate coast of California that really stands out more than anything else, where the interior still has seen warmer than average conditions so far this summer to date. And given the expectation of a much hotter August to come, well, again, we'll see where that shakes out. But this is what the season to date looks like. It's also worth noting, by the way, I'm going to pull up the precipitation percentile, that it's also been a really dry period. Despite all that precipitation that I mentioned in Northern California, it's been pretty spotty and isolated. So you can see a little area right around Mount Shasta that's actually near or above average. But in general, the last 2 months, it's been super dry across the Great Basin. It's been unusually dry in the Sierra Nevada. It's been unusually dry along the California North Coast and the Oregon Cascades. So actually, your experience in San Francisco of it being chilly, foggy, and drizzly, if we're talking about water supply across the broader West, if we're talking about wildfire risk in the mountains, a very different picture emerges of a period that has been exceptionally dry and warmer than average in many of California's forested regions and across most of the Great Basin. Now, where are we seeing big-time fires right now? Well, it's kind of in this region and then up in this region. So there is some notable correlation between these recent conditions and the fire conditions we're currently seeing. Okay, so what does the forecast hold next? Go over to the trusty Tropical Tidbits server here for some of the model representation of what's to come. Here we are right now. It remains relatively cool. We have a trough or a low pressure area sort of over California at the moment. Again, active mountain thunderstorms. It's not very hot. But if I step forward in time, looking at the forecast, this particular trough fades a bit. We might get one more this coming weekend, another low pressure system and trough. This could be yet another round of breezy conditions, northern mountain thunderstorms yet again, and cooler than average conditions for at least Northern California, although Southern California is starting to look a little different already. But if we step forward even farther in time, here is where things really start to change. So about a week from now, Southern California is going to start to experience potentially a significant heat wave. In fact, much of the Southwest will likely be. And unlike previous events this season, which kind of showed up in the models 2 weeks out and were perpetually 2 weeks out, this one actually did show up 2 weeks out and a week later is now 1 week out. So that's a sign of progression through model simulated time. This is more likely to actually happen, I think, than the last couple of rounds. Can't guarantee anything, but I think that this is likely the one to sort of break through. This is a pretty anomalously strong ridge, and if we look at the temperatures aloft, we see that these start to really expand to much warmer than average values across all of the Southwest and California as we move forward, as we step forward in time. So now we're sort of talking about 8 or 9 days out, so not this weekend, but next weekend. And this general ridginess really persists, potentially over California through the end of the outlook period through mid-August. So this is a very different picture. And now this is at the very end of the run, 16 days out. We still have anomalously strong ridging along the West Coast in general. And importantly, this is what the surface temperature plot looks like as we go forward. So I'll go back in time to now, near or slightly below average surface temperatures over the next 5 days. Again, that trough and is really producing this. But this really fades and pretty dramatically transitions to universally above average temperatures in the model ensembles right now across the West, and importantly, offshore waters too, as these waters warm up. This is a pretty large heat signal for the interior of Northern California for 2 weeks in the future. And this is a 5-day average as well. This isn't just a random snapshot. So I really do think that this is much more likely to actually come to pass. If we look at the European ensemble equivalent, I got to go back here, show where we are now. Again, it shows that trough right now. Shows one more coming through next week, this weekend. But then after that, similarly, a quite strong ridge builds, and more importantly, it does look like the western troughiness largely goes away, and we end up with warmer than average temperatures. Now, something that some folks have been pointing out recently, what is up with this blob of cool water along the coast still showing cooler than average temperatures despite a ridge aloft? Well, this is because the European model doesn't fully couple its ocean with the atmosphere, so it means it can't really assimilate the recent warming trend correctly. The American model, the GFS ensemble, actually seems to be doing a better job of representing the recent warming along the coast. So I would kind of ignore this blue blobbiness along the immediate coast here and focus more on the fact that everywhere else ends up being warmer than average during this heading into mid-August. That is the most likely outcome, and I think in this case it's probably better represented by the American GFS ensemble. As here. Also notable is that the 7-day precipitation anomaly is drier than average across the southwest, indicating the continued failure of the monsoon, and that doesn't really change dramatically through the end of the period. So not really looking like a good monsoon year, because we're going to get through potentially mid-August and still have below average precipitation in the key monsoon region. So that could keep southwest fire season going longer than most years. Okay, so I'm going to go back. I'm going to stop sharing. I'm going to go back. You see me full screen again. Take a look at the comments that have come in. All right, here. So I'm going to go through chronological order. Just a reminder, again, if you haven't caught the latest installment of the Climate Extremes documentary that I was involved with the production of, you can check that out via the link at the beginning of the chat. I included that again. So if you're looking for something to watch after the session or later in the afternoon, or maybe on a Friday afternoon under the marine layer, as that cool air continues this weekend, that might be a good time to watch it. Okay, there's a comment from Christina, hoping that the San Diego high desert gets monsoon moisture soon. Yes, as I mentioned, unfortunately, the prospects aren't looking great for that this year. Certainly not in the next couple of weeks. That said, individual monsoon surges are not well simulated by the models, and so there could be one that sneaks in under the ridge. At least with a ridge, the pattern is more favorable in general than with a persistent west coast trough, so I guess that's one step in that right direction. Thank you for the kind words, Scott, regarding these office hours. Yeah, Mary mentions that a local meteorologist, presumably earlier this week, compared tsunamis to large and fast storm surges, which makes sense. They are similar in that, I mean, the main difference between a storm surge, which would be, again, an elevation of the entire sea level by a certain amount, is that a storm surge is usually more gradual. It takes minutes to hours to rise, whereas a tsunami, it can happen essentially instantaneously, which is one of the big hazards, is there's a lot of energy behind the suddenness of the change, and it can catch people off guard. As well. Also, a tsunami is oscillatory. You can have a surge of water that then ebbs and flows. You can have retractions of the surface water. In fact, the surface, at times, you can get water that is well below usual sea level. As the tsunami sort of recedes temporarily, it's actually not a good sign, typically, when you see the water receding, as we did during this event earlier this week in some locations. But the tsunami is usually characterized by many waves, and often the first wave is not the largest. So sometimes people, and this was the story, of course, in Crescent City, in a couple of different tsunami events in the 20th century that were pretty damaging or even deadly up there, where the people did evacuate prior to the first wave, but then they watched that come in, it receded, and everyone thought it was over, and then they went back to town, and then the next wave came in, and it was significantly larger than the first. That's not uncommon. So just because the first wave isn't a disaster does not necessarily mean that subsequent waves in the minutes and hours that follow will not be. So that's an important consideration there as well. Mary also mentions the Cascadia subduction zone, which is off the coast of the Pacific Northwest. This is the main source for the worst case scenario tsunamis along the west coast of North America, so the Pacific Northwest, British Columbia, Alaska, and Northern California, because it would be a very proximal, very nearby potential for a very large earthquake. So it's generally believed that the Cascadia subduction zone could produce an earthquake of similar magnitude to what we just saw off the coast of Russia, near magnitude 9. And if that sounds like a really high number, it is. Again, these magnitude scales are logarithmic. So magnitude 7 earthquake, which is the kind of earthquake that has occurred near and in California in recent decades, is very small. Vanishingly small even compared to a magnitude 9 quake in terms of the energy released and the magnitude of a tsunami that could potentially be generated. The other problem is that not only is it nearby, and so the shaking would be pretty strong on land in the Pacific Northwest, but also it's so close that the tsunami that it would very likely generate would reach the coast quickly. And this is the big difference from even if there were a large tsunami from an earthquake in the West Pacific, the West Coast would have hours to prepare. Everybody should have plenty of time to get out of the way. The Cascadia event, that's not necessarily going to be true, because along the Oregon coast, there might be as little as 10 to 15 minutes between the earthquake and the initial tsunami arrival. That's not very much time in a place, because the Cascadia event could produce a very large tsunami on the order of 50 feet or higher. There's some modeling that suggests the upper end of what's plausible is even a 100-foot tsunami from a Cascadia earthquake. Lesser amounts are more likely, but even a 20 or 30-foot tsunami along the Oregon and Washington coast would be devastating and very likely deadly. So this is also an event that could, of course, affect California, particularly coastal Northern California, Crescent City, other coastal harbors up there being quite vulnerable again. California would probably have a little bit more warning unless for some reason this was at the very southern end of the Cascadia subduction zone, but still much less warning than the hours that we have from distant trans-Pacific earthquakes. So if you're really worried about tsunamis along the west coast of North America, arguably the one real event to be genuinely preparing for as sort of a plausible worst case would be a large Cascadia subduction zone event. And it is a matter of time, a question of when rather than if, but we might get lucky. It might not happen in the next century, or it could happen theoretically today or tomorrow, and we don't really have any way of quantifying, since unfortunately earthquakes appear to be really unpredictable, and that science has not really changed much in many decades. We don't have the specific ability to pinpoint when earthquakes are going to occur. There is a little bit of interesting study right now regarding foreshocks, by the way. So we do know that the 2011 megaquake off of Japan that produced just the absolutely devastating tsunami during that event was preceded by a couple of magnitude 7 foreshocks. That also appears to be the case now for this event off of Kamchatka. So there is a little bit of indication that maybe the very largest subduction zone quakes might have some sort of a signature. Still nothing that's obviously going to give you a specific enough warning to do much of anything with, but it's just one of those things that's out there lurking as a potential hazard in this part of the world. And something that I think some folks are less aware of. We'll think more about the San Andreas Fault or the Hayward Fault in California as being major hazards. There are, of course, other faults that can produce damaging earthquakes. And those are probably the two candidate faults that might cause the most damaging ground shaking in population centers in California. But from a tsunami perspective, those are not really faults that are very likely to produce a tsunami of significant magnitude. It really is the Cascadia subduction zone in the Pacific Northwest that's the greater concern from that perspective. Neil mentions visiting Honolulu and got stuck in evacuation traffic when everyone got told to go home at the same time. It was not good. Yeah, I was sort of surprised that there was so much gridlock in Honolulu. It's a good thing there wasn't a really large tsunami. In general, Hawaii's emergency management and civil defense evacuation systems are pretty good, actually, even compared to some parts of California and the Pacific coast. I think that's just an inevitable reality. One thing to realize is that, and I think this is important actually, thanks for the reminder, I've heard from a lot of folks who are very concerned whether they needed to evacuate, their location in coastal hills of California. We're talking like hundreds or even a couple thousand feet above sea level. If you're more than 100 or 150 feet above sea level, the answer is essentially always going to be you're fine in a tsunami event, that you really just let other people who are at lower elevations get out. Under all but the very most extreme events, even being 30 or 40 feet above sea level is probably good enough. So vertical evacuation is quite a viable option. There are most places you don't actually have to go that far to get 30 or 40 feet above sea level. This is the challenge about the Oregon coast, by the way, is there are some stretches of populated coast where you actually do have to go miles to get more than 30 or 50 feet above sea level. That's the big concern up there. But in most of California, that's not true. There are some suburbs of coastal Southern California where there's more concern, but in general, if you're in the coastal hills, you're fine. There's not going to be an earthquake-generated tsunami that's hundreds of feet tall or 1,000 feet tall. So just to give a sense of scale, a pretty big tsunami is 10 or 15 feet. An extremely large tsunami might be 50 feet, and the largest ones we've ever observed from an earthquake are on the order of 100 to 133 feet at their very maximum. And those are literally the very largest ones we've ever observed from an earthquake. You can get tsunamis generated by other mechanisms, more exotic ones like a giant undersea landslide, for example, a hypothetical risk that we can't really quantify, and out there in the tail, the distribution of big bad things that could happen and are pretty hard to prepare for, frankly, or something like a meteor impact. But again, at that point, we probably have bigger problems to deal with. Those kinds of events can generate much larger tsunamis, but it's sort of on the scale of things that even as somebody who thinks a lot about the ways that things can go wrong, I just tend not to think too much about them because they're very unlikely to occur. Unlike a earthquake-generated tsunami, which occur with some frequency, and which it very much does make sense to be prepared for. Interestingly, there was a mega tsunami observed on Earth just 2 years ago in Greenland, when a large chunk of essentially a rock face, a glacial wall in a fjord, fell into the water in that fjord and created a wave estimated to be around 500 feet tall, 500-foot tsunami. Granted, it didn't travel all the way across an ocean basin. It was trapped in this fjord, just sloshed back and forth. So very bad news if you're on an observation vessel in that bay. Much like the Lituya Bay 1958 tsunami event, again, a large collapse of a mountainside near a glacier into an inlet. In that case, that produced a tsunami that was apparently over 1,000 feet tall, again, in a very localized context. Those are not events that would produce very large tsunamis outside of a localized area. But again, these are, that's a different situation. California doesn't really have much of a risk of those kinds of tsunamis. We don't have any massive mountains and coastal fjords that could direct water directly onto the coast in that way. So generally speaking, in California, 100 and 150 feet is pretty much absolute safety in any foreseeable tsunami. And in the vast majority of events, even 30 or 40 feet pretty much gets you out of harm's way. If you're ever stuck in a place and you can't get out easily, and you're below that 30 or 40 foot mark, just going up into a building that's at least 3 or 4 stories tall is often a good option as well. So that notion of vertical evacuation. Oh, and you know what? I actually missed. I'll extend past the hour. I missed a whole segment that I want to talk about, the federal update. I'll do a 5-minute federal update now at the very end. I'm going to finish going through the comments here first. All right, here. So a question from Rachel. Where is the surface ocean warmth off California coming from? How deep does it reach? Is there still a vast, cool ocean underneath the surface? How long would it take to warm the entire depth of the ocean? Those are interesting, exam questions from a physical oceanography course, actually. They're good questions. But the short answer is that, generally speaking, the rapid warming off the coast isn't because there's some giant heat source. It's more that the coastal upwelling is shutting off. So we're no longer getting that really cold water from beneath. Essentially, there's a functionally infinite volume of cold water in the ocean. The ocean is very deep. It takes many decades for it to heat up, even with global warming. So there's always going to be a lot of cold water at depth if you can upwell it. The recent rapid warming along the coast is because we essentially killed off that upwelling. And now the lack of cold water coming up from beneath is allowing that surface water to slowly warm. So it's rather than really warm water coming in from somewhere, it's really a lack of cold water coming up from beneath, and then the sun, to the extent that we've got sun through the marine layer, is slowly heating that surface. But the bigger piece is shutting off the cold water tap rather than turning on the warm water tap. It's a mix of those two processes, by the way, with the broader warm blob across the northern Pacific. There's less upwelling to begin with. There is more surface heating. In that case, it's more of there's not much vertical mixing because of the stable high pressure and the strong sun, so it's heating up. Okay, so I mentioned the last thing I wanted to talk about today was a bit of a federal update. I've been offering these since last autumn, before the last election, which has had pretty significant consequences for the function and form of the federal government. And I've been really talking about it in the context of weather and climate and disasters. And you can refer to previous sessions if you want to hear those details. The updates I wanted to offer were this. I've talked previously about the proposed White House budget for lots of federal agencies like NOAA and NASA and etc. And the National Science Foundation, which both conduct day-to-day operations like weather prediction and ocean prediction and tsunami prediction, by the way, and also the research arms of these organizations, like NOAA Research, which really has multiple research labs scattered around the country that study everything from tornadoes to hurricanes to tsunamis to climate change to flash floods, and the communication, by the way, of watch and warning information in an effective way to the public. And also fund university researchers to do this. In fact, much of the science that gets done in the weather, climate, water space in this country is funded by federal agencies through research grants to universities to do that work relatively cheaply compared to essentially outsourcing that work rather than doing it internally where it would be more expensive. A lot of graduate students and postdocs doing that work for low wages, for example. But the presidential budget essentially zeroed out the research for weather and climate. Not just massive cuts, but completely zeroed it out in most cases. For NOAA, for NASA as related to earth science and climate, and sort of by extension weather. The other thing that had been happening was that a bunch of other actions had occurred. There was mass firing of NOAA employees for no particular reason. The probationary employees, again, who were both new hires and highly experienced people who'd just gotten a major promotion, those both classes of people who are probationary, were fired en masse for no reason. Some of whom are still, in fact, experiencing legal trouble. The government is going after them for back wages and health insurance premiums pretty incredibly after being summarily fired for no particular performance-related reason. But that's a sort of peripheral to the main point, which is that we, in February and March, saw mass firings in these agencies without any reduction in funding, Congress had appropriated the funding to keep these agencies running at their current levels. There was no lack of funds. Congress did not authorize a reduction in funding for the current 2025 fiscal year, and yet there were mandates by this pseudo-governmental entity known as DOGE. This was Elon Musk's project before, I guess, there was a falling out and he's no longer involved with the federal government. But before that happened, thousands of people were fired or were pushed out for reasons that were overtly political. And this meant that there were big gaps. So National Weather Service offices not functioning 24 hours a day in places like Sacramento and in Hanford. So this really did affect California, among other places. And it meant that many of the research roles were canceled. Research on wildfire and flash floods. A lot of this was canceled as people lost their jobs, as facilities were at least temporarily shuttered, as research projects came to an abrupt and unexpected close. And again, all of that not because Congress reduced the budget for these agencies, but because the executive branch and the OMB essentially said, we're not going to use the congressionally appropriated funds to do the things that they were appropriated for. We're just going to use what is sometimes called a pocket rescission, or really just a mechanism that remains poorly defined. Just, we are not going to pay you the contractually agreed upon payments to do the work that we agreed was worth doing. That's what happened earlier this year. Then there was this presidential budget proposal, which was shocking and horrifying, as we've talked about previously. As it was pointed out at the time, this still needs to go through Congress. Congress ultimately is the power of the purse. At least that's how the Constitution is supposed to work. And so ultimately, Congress is supposed to decide on this appropriations of bills that will go through later this year. They still haven't gone through the full process of reconciliation or votes yet, but the drafts exist. And the long story short, the initial congressionally suggested appropriations for all these agencies are nothing like what the White House suggested. They do not involve the catastrophic existential cuts that the White House has demanded for all of these agencies. So Congress has, some people are calling it a rebuke of the White House, and I think that's a reasonable interpretation. Where NOAA and NSF and NASA are all funded at much higher levels by the proposed congressionally proposed budgets reading these reconciliation bills than would have been the case for the absolute, complete, and total decimation in the White House budget. So comparatively, of course, that's good news, right? And I don't want to detract from that. I do think that that is partly a reflection of the enormous public pressure that has arisen in response to all of this. So that is relatively good news. And I do think that the budget that's ultimately passed is likely to be less dire, perhaps much less dire, than these initial White House proposals. That is the relatively good news. However, there are still different versions of these appropriations bills in the House and Senate. There is still a lot of pressure from the White House to reintroduce a lot of the cuts that had been not implemented in these initial drafts by Congress, and that's going to be a bit of a negotiation process. And also, there remains major concern that even if congressional appropriations for NOAA, for NASA, for NIH, for NSF, for all these 3- and 4-letter agencies that are funded by the federal government to do really important, critical work for the sake of Americans, even if that funding is provided at a similar level to what it is currently at, which, by the way, due to inflation, flat budgets are an effective cut, but I think in the current environment that would still be a major win relative to the alternative if that were the ultimate outcome, that even if these agencies are funded, that the federal government has already announced its intention, and the Supreme Court has actually sided with the executive branch in recent decisions that would push in this direction. Even if the money is allocated, it just might not be dispersed to the agencies that need it, that are to which it is appropriated for the purposes it is appropriated. And that is a big concern that folks, specific individuals like Russell Vogt, among others, have specifically said, if these budgets pass, we're just not going to give the money to the entities and the agencies that they're allocated to. Even if Congress overwhelmingly, even in a highly partisan environment, can come to an agreement that we really don't want to decimate NSF, NOAA, NASA, NIH, all these agencies, which I think is good if that is the decision that Congress ultimately comes to. But even if Congress says, yeah, no, we really don't want to get rid of these, and we don't want to decimate the American leadership in these spaces, there is likely to be major disruption to come still, as these funds that are allocated may not be paid out. That is where we are right now. That's the major concern. So the big update is that the budget from Congress is likely to be very different and much less dire in some respects than what the White House has proposed, although there are still major cuts involved, and it's not entirely clear exactly where the money is going to go. It may well be that there's an increase to, say, weather-related research, but existential cuts to climate change-related research is one possibility that remains, even within the current budget framework. But the broader concern is that through using tactics like pocket rescission or essentially executive branch appropriation, I'm not even sure if there are terms fully to describe what has been proposed because it really hasn't happened at this scale before, that we're not out of the woods yet, even if Congress ultimately approves a decent level of funding, a very much higher level of funding for these agencies than the White House has proposed. So that is speculation on my part. We don't actually know exactly where this is going to go. But again, I encourage people to read the documents, as I've been discussing since October of last year, that were intended as policy blueprints. Again, yes, I am referring to Project 2025, which has been implemented as essentially the letter of the law in many cases, even when it apparently contravenes some of what many constitutional scholars have interpreted as being the letter of the law in this space. And there is specific provision in there for how to get around Congress and how to contravene essentially the congressional reconciliation and appropriations budgets to achieve desired policy outcomes. So watch this space in the coming months. Another federal update, as I mentioned, this is a bit of a smaller issue, although it's not small if you're worried about hurricanes. The defense satellite operated by the U.S. Department of Defense, the scatterometer imagery, these older satellites that are really critical for hurricane prediction and sea ice monitoring, which we're going to be shut off, not just to public access, but even for internal NOAA access at the end of this month. So beginning tomorrow, at the peak of hurricane season, there was an emergency announcement yesterday or the day before that, in fact, due to public pressure, I don't think this was the full admission, but this is ultimately what happened. Due to internal pressure from NOAA forecasters and from researchers and the public, this satellite is actually going to be maintained for at least internal NOAA access. Not sure about public, but the more important piece is that NOAA scientists still have access to it. It sounds like they now will through the end of life of the satellite, meaning there will not be a gap in our ability to have this critically important data for things like hurricane prediction. So that is good news. That's a clear outcome where public pressure changed the outcome. So for all the folks saying that, you can't bear to listen to this, it sounds so awful, the point I really want to make is that by talking about this, outcomes have changed. I'm not saying that this particular YouTube channel is the progenitor of these changes necessarily, but having people talking about this to broader audiences, having the media coverage, having people contacting their members of Congress has had an effect. It is not the case that nobody is listening. So I do think that's an important perspective on this. So that's one relatively modest success. The other piece, and this is the final piece of the federal update today, is that there was a relatively devastating, I guess is maybe the way to put it, although not surprising, decision by the EPA to essentially revoke the endangerment finding regarding greenhouse gases. The endangerment finding, by the way, let me just plug in to the internet because I realized that I was actually doing this via Wi-Fi the whole time. Not so bad, considering. The EPA endangerment finding regarding greenhouse gases was a 2009 decision that the agency would essentially, that the federal government would be able to regulate greenhouse gases as a pollutant because they endangered the health, safety, and well-being of Americans. Not through direct toxicity, as might be the case for other pollutants like, arsenic or or particulate smoke or something, or mercury in the environment, or heavy metals, or radioactive waste. Those things have direct physiologic harmful effects on people that are, I guess, a little bit more intuitive. But the argument about greenhouse gases, essentially, it was that through their contribution to global warming and climate change and increases in extreme weather events and extreme heat waves and extreme downpours and extreme wildfires and all of that, that was the mechanism, an indirect mechanism, but a profound one, by which they harmed Americans. There's a lot of scientific evidence accumulated over not just decades, but arguably centuries, that this was a reasonable interpretation. And in fact, since 2009, the scientific evidence in support of greenhouse gases as something that harms humans in general, and specifically Americans, for the perspective of U.S. legal jurisdiction, was in fact absolutely correct. But the EPA has now officially announced this plan to abandon this finding, meaning that if that is the case, that greenhouse gases would no longer be regulatable as a pollutant in this country. That's a big deal, and it would mean the end to much federal regulation of tailpipe emissions and power plant emissions, and in regulations of how we generate our electricity in terms of the potential pollution outcomes, or even the kinds of cars and trucks that are allowed to be built and their relative energy or fuel efficiency. So it has far and wide-ranging implications. The basis for revocation, according to the federal government, is essentially that the harm to Americans by having less choice in SUVs and pickups in the marketplace, that the public health threat of not having access to larger SUVs and pickup trucks and high energy-consuming, low fuel mileage vehicles is greater than the threat of climate change to human health in this country. They have made these claims without presenting any evidence except for a hurriedly constructed report by, I believe it was either 4 or 5 hand-selected individuals who are well known to those in the climate community as people who have misrepresented the science of climate change for decades. In fact, some of whom have made a career out of it, who are paid primarily by interest groups and lobbyists and lobbying groups to offer a contrarian view, not supported again by any particular scientific evidence, but usually by cherry-picked statements and a very selective reading of. Selective is maybe even an overly generous word. A willfully misinformed reading of the existing scientific literature to create a 150-page report. The Department of Energy commissioned it. Apparently it was published in draft form this week. Very sparsely cited. I have read sections of this and skimmed the rest. Chock full of numerous errors, misrepresentations, and curiously does not describe the increase in temperatures or associated with warming in the United States at all in a report about the effects of global warming or lack thereof. I may have more to say in a more formal setting about this shambolic report later on, but the long and the short of it was clearly commissioned in a partisan political way. The report in no way represents the science, even the science as it existed, frankly, 20 years ago. It would have been an erroneous and misleading report decades ago, but much more so today, essentially serving as justification for abandonment of this endangerment clause. The federal government appears to be going to use this report as a basis for doing so. And again, I have a bunch of emails in my inbox from journalists. I need to make a more formal comment on some of the finer points in this report. But the bigger, the more important aspect here is this was a report that was pretty clearly commissioned to come to a preordained, misleading, and just simply false outcome that climate change does not present a major threat to the American economy or the health of Americans, which just isn't supported by any scientific evidence that any climate scientist I know, including myself, has ever seen. And that is only more true now today in 2025 than it was in 2009. And this is an extraordinarily weak attempt at trying to justify, through a highly selective reading of the literature. By the way, there's already numerous media articles where scientists who were cited in the report as having produced studies or evidence pointing to the benefits or the lack of harm of climate change, universally reporting to journalists that their studies were not only misrepresented, but in some cases were miscited, misappropriated, and completely mischaracterized on a fundamental level. So maybe I'll leave it at that for now. We're going to see how this plays out. The abandonment of the endangerment clause won't happen immediately. It's a proposed action right now. It is open for public comment, so anybody who wants to leave those comments can. It's not clear to me that those public comments are necessarily going to be particularly actionable. I'm not sure that that particular type of public comment is really going to make a difference. But right now, that's where we are. So it's a mix. The budget news is perhaps less dire, although still very much up in the air as Congress gets into the mix. The abandonment of the endangerment clause is indeed very bad news, even though it probably will take some time. There will be legal challenges, but in the meantime, as there are legal challenges, it will be abandoned, most likely. And the Supreme Court, based on recent decisions, may well end up upholding the ability of the administration to do what it wants to do in this case. Again, that's a prediction, but again, what we're seeing are a lot of end runs around the usual separation, the usual protections offered by the separation of branches of government from the legislative, the executive, and the judicial branch. And right now, things are not operating as they normally would. So a lot of the typical expectations and assumptions that we've applied historically regarding guardrails may or may not be relevant. I don't think we can always automatically assume that they are in the current environment. So that's veering dangerously into political science territory. I won't go any farther there, but I did want to offer that federal update because it has been a remarkable and tumultuous period, and every day there's new breaking news about what's going on in this space. So with that, I think I'm going to call it a day. Thank you again for joining this multi-layered session. I know there's at least 4 distinct topics, so if you missed one, once I push stop, it will be recorded for your viewing convenience after the fact. So with that, I think I'm going to close, and I'll talk to you next time.